Alrighty, in this video we're looking at rates of change. Now I thought I'd do an example with trigonometry just to mix it up a bit, but basically any of these questions are going to be actually mainly calculator questions which you can just work through and interpret the answers. So if you ever see the word rate, that means derivative, and if you ever see the word amount, that is just the normal function. So just keep that in mind. Now, what we do is we always graph. So if you ever see a rates of change question, graph it. Now, if you're using a Casio and you're dealing with trig, I really encourage you to use the little fraction button down here to deal with that. Otherwise, you might run into some bedmass errors, but we'll do that. I'm going to draw it, and my function looks horrible. First of all, make sure you're in radians if you're graphing a trig function. So there I can just make sure the angle is in rad. And let's see, what does t represent? T represents the time in hours. So let's look at a single day. So I'm going to go from 0 hours to 24 hours. And we're looking at a temperature here. I don't really see the temperature getting much hotter than 40 degrees, at least hopefully not. So let's see what that graph looks like. And that looks like a good temperature graph. State the maximum and minimum temperatures on the farm. So pretty much if you want your G-solve max, there it is, 1625. And then the min is going to be, well, shift G-solve min, 415. So here, max temp is 25 degrees Celsius at, now that 16 would be 4 p.m. because 0 is 12 a.m. Min temp is 15 degrees Celsius at 4 a.m., just like that. Find the temperature at each of those times. So this is where we just use trace on the calculator. So we're going to go shift trace, and then we're going to type 6 for 6 a.m. So I'm going to notation wise say that T of 6 is, and then it's this number 15.7. Now I'm going to give 3 significant figures here just because SACE exams tend to like that. T of 12, so shift trace, and then it's going to be 12, 22.5. Now it's going to be a strict equal sign because we haven't rounded it at all. And T of 18 is going to roughly equal, let's see, shift trace, and then we're going to go 18, 24.3. Cool. And now this is the temp at 6 a.m. temp at 12 p.m. and the temp at 6 p.m. Make sure you label those. All right, now it's asking for the rates of change at each of those times. So we're looking at T dash of 6, T dash of 12, and T dash of 18. So let's see if we can get those. You're going to go trace, and you're going to go 6 for the first one. Now your dydx value should be showing there. If it's not, I want you to go shift setup and then turn derivative on. That'll make it show. But it's 0.6544. Now the units on this, whenever you're dealing with a rate, basically this temperature graph looks like this. It's big T in degrees Celsius, and it's little t in hours. So for the unit on the derivative, think of it like this. To t, the unit will become degrees Celsius on the top and hour on the bottom. Degrees Celsius per hour, that's going to be the temperature increasing or decreasing. All right, T dash of 12. So let's look at that. Shift trace, and then we're just going to type 12, 1.13. Degrees Celsius per hour, and T dash of 18, if we do that, we're going to get minus 0.654. If you want to interpret it, basically the temperature is now decreasing at that last one, but before it had been increasing all the way up there, or at least at those specific times we looked at. And then you just chuck in this little description here. Okay, if the temperature falls below 18 degrees Celsius for more than 7 hours in a row, the crops will die. Determine whether or not the crops will die. So 18 degrees Celsius for more than 7 hours. There's a couple ways to do this. So one way is to graph a line at 18 and then sort of look at when it's below that red line. The other way is to use xcal. Now, if you see that line at 18 there, it actually does sort of go off to the left. And I'm actually being a little bit cheeky with this question because we could go up as high as we want and do lots and lots of different days, like heaps of days. But basically, we want to know how long this period is when it drops below. So you could go and intersect those two lines and you'll get those times. So it appears to be at 23.6. So it's below 18 from T is 23.6 to T roughly equals. And then we can just hit over to the next one, 32.428. Now, since this repeats itself, that 32 that I just found will be equivalent to that 8.428. So like 8.428. All right, probably worth converting these back to times. But before we do that, I might just show you that you don't need this line at 18. If you do want, you can just go draw, Shift G solve, scroll across xcal and type 18 for the line value, and you'll get all those same numbers. Okay, so let's convert these back into hours and minutes. So if we're looking at this 23.6, I'm going to take the 0.6 bit and times it by 60, so 36. This is 11:36 p.m. 2, and then this one here, or if I use the 8.43, it doesn't really matter. I'm just looking at 0.43 there, times 60. Let's see what we get, 25. So 8, let's just go 26 a.m. Let's see, 11:36 up to 8:26. So that looks like more than 7 hours to me. So the crops will die, unfortunately. Very bad. So basically just figure out what that time is, and you might actually just want to comment on the fact that this is approximately, let's see, it would be 7 hours and 50 minutes. Actually, scratch that. I'm really bad at doing maths with times. It's 8 hours and 50 minutes. My bad. When you do this, you can also just subtract the t-values directly from each other. So if you do 32.4, take 23.6, you'll get 8.8, which is 8 hours and 50 minutes. But still, the crops are going to die. Find t'-t and hence find the times where all that's happening. So there's the function itself. If we want to look at t', we essentially have to use the chain rule. A pi over 12 will come out the front, and the sign will go to cos. If we want t', another pi over 12 is going to come out the front. So I'm going to get 5 pi squared over 144 now. Sine of pi over 12, t take 10, and that'll also become minus. Now, find the times when the temperature is increasing at its fastest rate. So if we look at the graph, and we might just go back to looking at our single day view. There it is. We'll set that window to go and finish at 24 hours. So really, I would be looking for that inflection point where it's going straight up. So just have a quick look at that. There we go. So I would like to find that inflection point, and that's probably why they've asked us to find t'. All right, so let's work with that. So we'd like to solve for 0 equals t'. So 0 is minus 5 pi squared over 144 sine of pi over 12 t take 10. Now this looks worse than it is because you can just get rid of the whole constant out the front. And then you want to look at something like a unit circle. So basically, when does sine equal 0? It happens at 0, 2 pi, happens at pi. And if you keep going around the unit circle, it'll just keep happening. So all that stuff, pi over 12, t take 10, that's the thing inside the sign, that has got to equal whatever makes sine 0. So 0 or pi or 2 pi or 3 pi or etc, etc, etc. Now we can start sort of rearranging this equation. First thing that I'm going to do on both sides is I'm going to times by 12 over pi, essentially to get rid of that constant out the front. But now I'm going to need a times by 12 over pi for each one. So what we're left with is that t take 10 is 0, or pi times 12 over pi, so that's 12, or 24, or 36, and then we just add 10 to both sides. So we'll add 10. So that tells us that t is going to be 10, or 22, or 34, or 36, etc, etc. Now what we've done is we've found our points of inflection. So I would say this one happens at the t equals 10 value we just found. And then this point of inflection over here would be the t equals 22 one that we just found. When is the temperature increasing at the greatest rate? It's this one. Now, if you wanted to look at like 34, that would also correspond to a time of 10 a.m. And then this one here is 10 a.m. too, just like that. Now, this list does keep going on forever because the day is going forever, at least as far as the mathematics is concerned. Sometimes they might ask for what the temperature is at that point. So if you were just curious about that, you could just trace at 10. You can see that is highlighting our point of inflection, and the temperature is 20 degrees. So just in case they ask that follow-up question as well.